Okay. So a whole number is a number with no parts beginning with 0. So Brady was correct, but if you just say numbers bigger than 0, it could be like 1.7, right? And that's not good. Who's up for what a real number is? Kayla?
A number with no decimal.
No. Good try though. Layla?
Is it a number above 0?
Maybe, but there's a lot more to it. Brady?
Any number.
How about any number? Any number you can think of. It is real. Kayla?
Could it be like a fraction?
Yep. Anything. Any number you can think of, negative, positive, part, whole, whatever, it's real. Integer? You silly people. John?
A number with a decimal?
No. Emma?
The rational number?
No. Ryan?
Is it like positive and negative numbers?
Yes, but we need a little fine
With
tuning.
those lines?
What lines?
Absolute value.
Yeah.
Oh. There's some ties into that, but how about this? A whole number, which we already defined, right? I guess I shouldn't say, I should say whole numbers. And their opposites. So a whole number, 0, 1, 2, 3, 4, their opposites would be your negatives. 0, -1, -2, -3, etc. Right? So Emma, you mentioned rational. What's rational? You know that one? No? Anyone? Brady?
A number that has an ending?
Yes. Yes. Kayla? No. No. Okay. Rational number is fraction. A fraction. Or a terminating decimal. What's a terminating?
An ending.
One that ends. Whoa.
You really had to shout that?
I'm sorry?
I was talking to Brady.
I just need more room. I'm not, see, these are reminders. If you guys looked in your 6th grade notebook, you would see this. It also includes pattern decimals too, but rational numbers. 1/4, 0.25. 1/3, 0.3 repeating. 7, -6 1/2. Okay, we'll get into that a little bit more. Irrational, Ryan.
Like a number like 5 is an example that does.
So we're gonna just say not rational. And that means numbers that don't do this. So a number you can't write as a fraction or as a decimal, it doesn't have a pattern and it keeps going. So like Ryan said, pi. Square root of 5. Remember square roots last year? Yeah. 0.127654 ... You don't know what the ... is. Right? Last one. Natural. John? Kayla?
No decimal fraction.
You are correct. What did we call them? Do you remember?
No.
Ryan?
Is it like the numbers that you count times?
Counting numbers. So where does we're all review, and I know just by doing that, I'm not expecting that necessarily to stick, but we'll do it enough that you will know those definitely a lot more as the year goes, and we'll continue even learning them and reviewing them in the 8th grade, okay? But the one that we are going to concentrate on is integers. How many of you saw either on Alex or, I don't know, anywhere, stuff with like negative and positive numbers, like adding -3 plus 5, or 4 times -2, stuff like that? Hi.
Hello. I'm just visiting.
I'm recording. That's okay.
I'm
You can
sorry.
come in. You want to come in and say hi?
My camera.
Yep.
Hi, remote learners. Nice to see you. Bye, remote learners. Sorry about that.
No problem whatsoever. So integers, we're going to be looking at what the rules of integers are. And last year, I think all we did with integers was to determine what's the opposite, where it was on a number line. And then like Ryan said earlier, absolute value, right? You remember those things? So if you're done with this sloppy slide, I'm going to go to the next one. Are you good?
Yes.
Okay. What color should we use?
Yellow.
Purple. You said yellow. Yellow's not even on there. That's not yellow.
That's for you.
It'll do. Now, I want you to know that these rules that we're about to go through really do apply to all real numbers. They apply to rational numbers, but we're going to work with integers first because we don't have to think about common denominators and lining up decimals, and I just want to get the rules down first. Then we definitely will relate that to rational numbers after that. Okay? So one thing I want to make clear is my little key here. When I use a capital P, I'm talking about a positive number, and obviously an N is going to go to the word negative. Okay? And also these rules are applying right now to 2 numbers. You certainly can add many more numbers than 2, but this rule applies to 2 numbers. Okay? So let's see. This one you know. Have you learned stuff like 3 plus 2?
Yes.
Oh. Tell me, how do you add those things? How do you know how to add 3 plus 2? No, we raise our hand. Caleb?
Well, you don't count your fingers, but like,
You don't count your
for like 3, you add.
You have, go ahead, you have 3.
Well, you have 3 fingers, and you add 2.
Okay, so you have 3 somethings, right? And you add 2 more of the same something, and you're able to count them all up. Why can I count them all up?
Why?
Yeah.
Can you?
Yeah. What?
Because you like have numbers.
Yeah, but I mean, the answer to this question, although very obvious, is important to know the rest of these rules. That's true. Ryan, what are you thinking?
How to add up 3 and 2.
Yeah.
So first you have to know the values. You know that 3 is worth 3, 2 is worth 2. You know that 2 is 1 plus 1. Now if you add 1 1 to 3, which is a lot easier, you can just count with your fingers. That's 4, and then if you add the other one, then you count.
Believe it or not, I follow what you're saying. So we have 3 things. He's just saying every time you add 1, it increases it. So adding 2, it just keeps increasing it. The answer to my question, though, really is, why can you add them? Because they're the same, right? If I have 3 fingers and I add 2 more fingers, I have 5 fingers. If I have 3 students and I add 2 more students, I have 5 students. Those are integers. You've been learning integers ever since you were, what is that? Kindergarten, do you start writing? Good. You've been learning for a long time. So if I have two negatives and they're the same, what do you think's gonna happen, John?
Well, depending on the negative,
No, I'm sorry to disagree with you. Can you explain how that would happen?
well, if you were to have negative, oh wait.
Okay. Let me tell you, we'll wrap this one up. If I have two of the same thing, I gotta have the same thing. Okay? We're gonna stop it here and I'll continue it tomorrow, okay?
We are doing after lunch.
I can stop.
Stop.
No, it did not stop.